Okay, good afternoon everyone. So we are continuing with chapter 10 part 2, which is on Doppler Effect. Okay, so I think Doppler Effect is quite famous, but the question is, do you understand what it is, right? So I have a scenario for you. So I'm in the car, right? I'm driving, I'm in the car and I stay stationary because there's a traffic light and it's red, so I have to stop. And then there's an ambulance behind me, and it approaches me and it goes forward lah. It is approaching me lah. So how does an ambulance sound like? It goes nino nino, right? And as it comes closer to my car, I'm hearing the frequency of the nino nino as nino 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 nino. The frequency is higher. When the frequency is higher, maksudnya the repetition is more, kan? Mula-mula ada nino nino nino, and as it comes closer to me, the frequency becomes higher and the repetition, which means that the repetition is more. So it becomes nino 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 as it comes closer. And then when this now the ambulance is next to me and now it goes forward. As it goes forward, it is going further away from me, right? It's going further and further away from me until I no longer hear the siren. And as it goes further and further away from me, the siren now sounds like ni no ni no ni no. The frequency is now lower than the original that I heard before. So mula-mula dengar ni no ni no ni no ni no as it comes closer to me, and then ni no ni no ni no ni no ni no until you can't hear it at all. So that is the Doppler effect. The frequency that you hear is dependent on whether the source is approaching you or is further away from you. I am the observer, the source is the ambulance. That scenario, let's continue with our class. So the Doppler effect is experienced whenever there is relative motion between the source of wave and the observer. So ada dua orang kat sini, satu jadi source, satu jadi observer. So the guy on the bicycle is your observer, yeah, and your source is the source of the sound lah. So when the source and the observer are moving towards each other, the observer hears a higher frequency. Like I mentioned before, kalau ambulance tu makin dekat, dia punya repetition rate tu makin tinggi. So jadi ni 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 ni. And when the ambulance is further away, bila ambulance tu jauh pada kita, dia punya repetition rate tu berkurang. So jadi ni 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 sampai it's totally gone lah. When the source and the observer are moving away from each other, the observer hears a lower frequency or the lower repetition rate. Okay, moving on. Okay, so we've talked about the equation. We talked about what happens when our source is not moving, but our observer is moving. Okay, so this is your source is stationary and observer is moving. Okay, so the equation becomes mana equation dia? Okay, it's this guy. Equation becomes frequency naught. This is the frequency of the observer. This is the frequency of the source. This is the speed of air at room temperature. Okay, and then this is the speed of the observer. Okay, and this is the speed of air. Okay, so that is very messy. So frequency of observer equals to frequency of the source dalam kurungan. V is the speed of air, V naught is the speed of the observer. So O ni referring to the same thing lah, observer over V. So this part of the equation is only for the observer. This part of the equation is only for the source. We will look at this later on how we will use this for the source. Okay? So frequency of observer is equal to the frequency of the source times with the ratio of V speed of air plus the speed of observer divided by the speed of air, assuming that the source is stationary. Okay? Okay, let's use orange. So this is the case when your observer is moving towards the source. So this is my source, this is my radio. and this is a cycler, orang yang tengah naik basikal ni, it's moving towards the source. This guy punya V is 0. The speed of the radio is 0, but the speed of the observer or the cyclist is 20 meter per second, let's say lah. Okay, so what should I do here? This guy is plus 0. This guy plus 0, so dia jadi V je lah. Plus 0, and this guy becomes, I just substitute my number, which is 20 meter per second. Okay, so I will get a frequency that is higher, right? Because speed of air plus 20 divided by speed of air will give me something that is greater than 1. So the frequency of the observer will be greater than the speed of the source. So, maksudnya dia akan dengar repetition rate tu higher. So like that. Okay. So if my cyclist is moving away from the source, okay, it's moving away from the source, intuitively or logically, the observer will hear a lower repetition rate. Lower repetition rate, maksudnya dia akan ting ting ting, and it goes lower and lower sampai tak dengar. Lower repetition rate. Okay, so what happens here? Instead of a plus, you get a minus. V minus the speed of the observer divided by the speed of the air. So you will get this as less than 1, which means that the frequency of the observer will be less than the frequency of the source. Which means that it is going lower lah. The frequency is lower. When you are moving towards the source, the frequency becomes higher. Okay, so that is the case when you are the source is stationary and the observer is moving. Now let's take a look what happens when we have a moving source. Now we have a source in motion, but the observer is not moving. Okay, so the equation is still the same, but we have a different, this time since our observer is not moving, so this guy becomes plus minus 0, which is just a V, and this guy is V minus Vs if you are approaching, if the source is approaching the observer. Kita balik tadi kita plus kalau moving towards the source. Now if the source is moving towards the observer, it's a minus Vs approaching the observer. So when the source is approaching the observer, what happens to the equation? This becomes a smaller, right? This becomes smaller, so this guy becomes greater than 1. Greater than 1. Becomes greater than 1. And which means that when it's greater than 1 and it is multiplied with the frequency of the source, you get F0 that is greater than Fs. This is when your source is approaching the observer. So this is your source, it's approaching observer A. So what is the frequency heard by the observer? It's a repetition rate that is higher than the frequency of the source. However, the observer B, the source is moving away from her. So what happens? So now your equation is this guy becomes a positive because it's moving away. So this is the speed of the source plus with the speed of air. So now this ratio becomes less than 1. When this guy becomes less than 1, multiply with the Fs, you get F0 that is less than the Fs. So the repetition rate heard by the observer B is lower. Sebab source tu moving away. Observer A is listening to a higher repetition rate. Okay, let's do an example. Two trains on a separate tracks that moves towards one another. Okay, so ada dua train on separate track. Okay, so this is the first track, and we have a second track and another train, and both of them are moving towards each other. Yeah, train 1 has a speed of V equals to 130 km per hour, and the train 2 has a speed of 90 km per hour. Okay, so let me write that properly. So V equals to 90 kilometer per hour. Train 2 blows its horn. So this is 1, this is 2. Train 2 blows its horn, so it becomes the source, right? Emitting a frequency of 500 Hertz. So Fs equals to 500 Hertz. What is the frequency heard by the engineer on train 1? This is train 1, this is train 2. So kita nak tahu apa frequency heard by train 1. So this guy now becomes the frequency of the observer. Take the speed of sound in air to be V equals to 345 meter per second. Okay, so remember your equation. So it's F naught equals to Fs, and we have V, which is the speed of air, plus with the speed of the observer, over V, the speed of air, minus the Vs, minus the speed of the source. This is the situation where you have a moving, the observer is moving towards the source and the source is moving towards the observer. And this is the situation or the equation when you have your observer away from the source and your source is moving away from the observer. So V minus V naught, V plus Vs. So it's terbalik lah, it's terbalik. So moving towards is positive up here, negative down here, and this is away. You have a negative up here and a positive down here. Okay, so now they are moving towards each other, which means that the source is moving towards the observer is also moving towards the source. So we will use the first equation. So let's plug in the numbers. Okay. So let's plug it in. Fs is 500, that is given. Your speed of air is 345 meter per second plus the V of the observer. Now this guy is in kilometer per hour, which means that you have to convert it to meter per second. As always convert to SI unit. So let's do that really quickly. 130. Bentar, sekejap. Okay, so 345 plus with the V observer. Our observer is train number 1, this guy over here. So that is 36.11. And V, the speed of air, minus Vs, the source. The source is 90 km per hour, and I converted that to the SI unit. We get 25. Okay, so now I can solve for my frequency of the observer or the engineer on train 1. So that is 345 plus 36.11 divided by 345 minus 25 times with the 500. So you get 595.48 Hertz. This is your final answer. Now, your frequency of the observer should be greater than the original frequency because you are moving closer to the source, right? So 595 is obviously greater than your frequency of the source. So that is correct. So let's see the answer. Okay, so it's correct. So now to conclude this part of the chapter, let's take a look at the equation. Okay, this equation, the general formula. Okay, so this is to conclude the Doppler effect. So you have frequency of the observer equals to Fs. You have V plus V naught and you have V minus Vs. And rearranging this, you get a ratio of F naught over Fs equals to V plus V naught over V minus Vs. Sama je, you just rearranging the equation. And again, the air is considered as stationary. We assume that the air is not moving. And the speed of air is given as 345 meter per second. Assuming that this is at room temperature, at temperature of 24 degrees Celsius. Okay, you can calculate this for yourself to know. You already know how to calculate this. This is the speed of sound in air that is at temperature 24 degrees Celsius, and you use positive values when observer and source approaches. So kalau positive value, this guy becomes positive, this guy becomes negative. Use negative values when observer and source are moving away. So kalau pakai negative value, this equation becomes negative and this guy becomes a positive. So terbalik je tadi lah. Okay, so this is the general formula that you should remember. Okay, apart from chapter 10 part 1, which you have 3 equations, this is your 4th equation. Remember the general formula: moving away positive, moving towards is positive value, moving away gives you negative value. Just plug it into this equation, you will get the answer. You have first, but before you can use the equation, you must understand the scenario first. Okay,